This is SpaceTime, Series 25, Episode 77. Coming up on SpaceTime, NASA's Curiosity Mars rover finds organic material on the red planet comparable with that found on some parts of Earth. It's all systems go for NASA's Viper lunar rover mission, and the unexpected chemical complexity of Comet 67P Churyumov Gerasimenko. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists measuring total organic carbon in Martian rocks for the first time have found levels comparable with some locations on Earth. Total organic carbon is a key component in the molecules of life. The new findings, reported in the Journal of the Proceedings of the National Academy of Sciences, shows there's at least 200 to 273 parts per million of organic carbon in these red planet rocks. And that's comparable to, or even more, than the amount found in rocks in some places on Earth, such as the Atacama Desert in South America. The data was gathered by NASA's Mars Curiosity rover, which has been exploring the red planet's Gale crater. Curiosity is advancing the field of astrobiology by investigating Mars's habitability and studying its climate and geology. The car-sized six-wheeled robotic laboratory landed on Mars almost a decade ago in August 2012 on what was meant to be a 2-year primary mission to determine if the red planet could ever have supported life. It quickly resolved that question with a very firm yes. The new study's lead author, Jennifer Stern from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says total organic carbon is one of several measurements that help scientists understand how much material is available as feedstock for prebiotic chemistry and potentially biology. Put simply, organic carbon is carbon bound to a hydrogen atom. It's the basis for organic molecules, which are created and used by all forms of life. However, organic carbon on Mars doesn't prove the existence of life there, because it can also come from non-living sources, such as meteorites and volcanoes, and it can be formed in situ by surface reactions. Organic carbon's been found on Mars before, but prior measurements only produced information on particular compounds, or represented measurements capturing just a portion of the carbon in the rocks. The new measurements are giving the total amount of organic carbon in these rocks. Although the surface of Mars is inhospitable for life today, the Curiosity rover has confirmed that billions of years ago, Mars was a warm, wet world with a thicker Earth-like atmosphere and liquid water flowing in rivers and streams. There was even a vast ocean covering much of the planet's northern hemisphere. Since liquid water is necessary for life as we know it, scientists think Martian life, if it ever evolved there, could have been sustained by key ingredients such as organic carbon, if it was present in sufficient amounts. The rovers drilled samples from 3.5 billion-year-old mudstone rocks in the Yellowknife Bay Formation area of Gale crater, the site of an ancient Martian lake. The mudstone in Gale crater was formed as very fine sediments from the weathering of volcanic rocks in water, which then settled at the bottom of the lake and was buried. Organic carbon was part of this material and became incorporated into the mudstone. Besides liquid water and organic carbon, Gale crater hosted lots of other conditions conducive to life, such as chemical energy sources, low acidity, and other elements essential for biology, such as oxygen, nitrogen, and sulfur. Stern says that basically this location would have offered a habitable environment for life had it ever existed on Mars. To make these measurements, Curiosity first drilled a sample of the Martian rock, then supplied this to its Sample Analysis at Mars instrument, which is basically an oven, which heated the powdered rock to progressively higher and higher temperatures. This experiment used oxygen and heat to convert the organic carbon to carbon dioxide, with the amount then measured to get the amount of organic carbon in the rocks. This experiment was actually performed back in 2014, but it required years of analysis to understand the data and put the results in context of the mission's other discoveries at Gale Crater. The resource-intensive experiment was performed only once during Curiosity's 10 years on Mars. The process also allowed Curiosity to measure the carbon isotope ratios, which help scientists understand the source of the carbon. Isotopes are versions of elements which have slightly different masses due to the presence of one or more extra neutrons in the nucleus of their atoms. For example, carbon-12 has 6 neutrons, while the heavier carbon-13 has 7. Since heavier isotopes tend to react a bit more slowly than lighter isotopes, the carbon of life is richer in carbon-12. Stern says in this case, the isotopic composition can really only tell them what portion of total carbon is organic carbon and what portion is mineral carbon. While biology can't be completely ruled out, isotopes can't really be used to support a biological origin for this carbon either. That's because the range overlaps with igneous or volcanic carbon and meteoric or organic material, which are the most likely sources for this organic carbon anyway. This is SpaceTime. Still to come, as all systems go for NASA's Viper lunar rover mission, and the unexpected chemical complexity of Comet 67P Churyumov Gerasimenko. All that and more still to come on SpaceTime. NASA's planning to land a lunar rover in the moon's south pole next year. The mission will search for water ice in the permanently dark shadows lurking at the bottom of craters that have never seen the sunlight. The water found by the Viper mission could ultimately be used to help sustain humans exploring the moon and could even be converted into rocket fuel. Most of the moon is completely dry without water. That's because of the way it was formed 4.5 billion years ago, through a giant impact between the early proto-Earth and a Mars-sized planet, probably a Trojan, called Theia. The impact caused both bodies to melt, forming a magma ocean, which eventually solidified into the Earth. However, some molten impact ejecta from the collision was sent into orbit around the nascent world, which eventually coalesced to form the moon. Of course, those temperatures were so high any water that was present would have evaporated and degassed into space. But over the following 4.5 billion years, meteors and comets containing water ice bombarded the moon, releasing water ice molecules across the lunar surface. Now, a lot of this water ice would simply have melted and sublimated back into space. But because the sun's angle at the lunar poles is steep, creating long shadows, the floors of some deep craters would never receive any direct sunlight, and so they'd be in permanent darkness. And that would result in some of the coldest temperatures in the solar system, just a few degrees above absolute zero. So any water ice deposited in these craters would have remained there, frozen in time. To find this valuable resource, NASA have developed the Volatiles Investigating Polar Explorer rover, or Viper. It's a golf cart-sized robotic laboratory designed for the extremes and unknowns of the moon's south pole. The rover, which will travel over several kilometres over several lunar days, that's about 100 Earth days, will assess things like what form the water is in, how much water's there, whether it's likely to be frost on the surface or ice at depth, and whether there's more of it in some areas than others. Currently being assembled at NASA's Johnson Space Center in Houston, Texas, Viper's being customized to meet the specific conditions it'll encounter at the moon's south pole. There's the cratered soil with various levels of compaction, requiring 4 independently controlled wheels that can handle slopes up to 30 degrees. Then there's the moon's drastic temperature swings, which range from 107 degrees Celsius in the sun during the day down to minus 240 degrees in those permanently shadowed areas. Viper is designed to handle those immense temperature swings. And it's designed to handle the darkness of those long lunar nights as well, being equipped with the first headlights ever used on a rover in order to illuminate places on the moon that have never seen sunlight. Of course, as with any space mission, there are the conflicting needs of science and logistics. The science calls for Viper to spend its time in the shadows, but the rover will also need to periodically climb out of the craters in order to recharge its batteries in the sunlight. Most rovers' solar arrays are located on their roofs, but the angle of the polar sunlight requires Viper's arrays to be mounted on its sides instead. To track its position and orientation, Viper is equipped with accelerometers, devices that are typically used to determine changes in position and rover tilt. Accelerometers are extremely sensitive and can detect even minuscule changes in gravity, such as that experienced as you roll over an ore body of different density to its surroundings. Known as gravimetry, it's already being used for mining prospecting on Earth and by rovers on Mars. Viper is part of NASA's Artemis program, a multi-phase project to return humans to the lunar surface, this time to stay. Artemis 1 is slated to launch in a few weeks' time, carrying an unmanned Orion capsule beyond the Moon and back to Earth on a 4-week test run. If all goes well, it'll be followed by Artemis 2, which will carry humans on a trip around the Moon and back to Earth in 2024. And if that goes well, the Artemis 3 mission will return people to the lunar surface sometime around 2025. And Viper will help prepare the way, launching next year to help explore the terrain in advance. This report from NASA TV.
We know from decades of study that the Moon has water, but where and how much? In 2023, a robotic rover will explore the Moon's surface in search of water ice. NASA's Viper moon rover will perform the first resource mapping mission on another world, using advanced instruments and tools to determine the location and concentration of water on the Moon.
To send Viper to the Moon, we're leveraging industry as part of our Commercial Lunar Payload Services program, a program designed to send science instruments and technology payloads to the surface of the Moon. Viper represents a very different development paradigm. We are developing each instrument for launch on Eclipse ahead of Viper, totally flipping on its head how we normally do this. This is truly creative. An industry partner will launch Viper to the Moon's South Pole. This is a place where no human or rover has ever been before.
The rover's survey will provide scientists with the most detailed view of the Moon's water to date and point to spots where water could be harvested by future astronauts.
Viper will be the first resource mapping mission on the surface of another celestial body. It represents a new kind of mission for NASA in which the objectives of advancing science and human exploration are closer than ever. The measurements that Viper's instruments will make can help us understand the source and distribution of the water and other volatiles on the Moon, giving us insight into the evolution of the Moon and the Earth-Moon system. The Moon's water is also a precious resource that could be extracted to support human exploration of the Moon and beyond. What we learn from Viper will bring us a step closer to developing a sustainable, long-term human presence on the Moon.
And in that report from NASA TV, we heard from Associate Administrator of NASA's Science Mission Directorate, Thomas Sabukin, and NASA Planetary Science Division Director, Laurie Glaze. This is SpaceTime. Still to come, the unexpected chemical complexity of Comet 67P Churyumov Gerasimenko. And later in the science report, scientists discover 480 million-year-old spore-like microfossils in ancient Australian rock. All that and more still to come on SpaceTime. Scientists have discovered a whole series of complex organic molecules in Comet 67P Churyumov Gerasimenko. Comets are ancient fossils from the depths of the early solar system, relics from the formation of the sun, planets and moons. Back in the mid-1980s, a number of spacecraft, including the European Space Agency's Giotto mission, studied Comet P1 Halley during its 1986 close encounter with the Earth. On board were several spectrometers. These measured the chemical composition of both the comet's coma, that is, its thin atmosphere due to sublimation of cometary ices close to the Sun, and also that of impacting dust particles. However, the data collected by these instruments back then didn't have the resolution needed to allow for an unambiguous interpretation. But fast forward 30 years, and the high-resolution mass spectrometer aboard the European Space Agency's Rosetta spacecraft is a generation more advanced. It was used to undertake a detailed spectra of the comet 67P Churyumov Gerasimenko between 2014 and 2016. And these observations, reported in the journal Nature Communications, have now for the first time allowed scientists to shed light on the complex organic composition of this comet. When Comet 67P reached perihelion, its closest orbital position to the Sun, it became very active, and sublimating cometary ices created an outflow which dragged along dust particles. The expelled particles were then heated up by the solar radiation to temperatures beyond those typically experienced on the comet's surface. This allowed larger and heavier molecules to deabsorb, making them available to the high-resolution mass spectrometer aboard Rosetta. Now, due to the extremely dusty conditions, the Rosetta spacecraft had to retreat to a safe distance a bit more than 200 kilometers above the cometary surface in order for the instruments to be able to operate safely under steady conditions. Still, it was possible to detect species composed of more than a handful of atoms which had previously remained hidden in the cometary dust. The study's lead author, Nora Haney from the University of Bern, says her team successfully identified a number of complex molecules which had never been found in a comet before. These included naphthalene, which is responsible for the characteristic smell of mothballs, benzoic acid, a natural component of incense, and benzaldehyde, which is often used as an artificial almond flavour for foods. Haney says these heavy organics would make Comet 67P's scent even more complex, but also more appealing. As well as these fragrant molecules, other prebiotic molecules are also identified in the spectra, including formaldehyde, an important intermediate in the synthesis of biomolecules such as sugars and amino acids, which are the building blocks of life. Haney speculates that it therefore seems likely that these impacting comets, as essential suppliers of organic material, also contributed to the emergence of carbon-based life on Earth. In addition to the identification of individual molecules, the authors also carried out a detailed characterization of the full ensemble of complex organic molecules in the comet, placing it in the larger solar system context. It turns out that on average, Comet 67P's complex organic budget is identical to some soluble parts of meteoric organic matter. And apart from the relative amount of hydrogen atoms, the molecular budget of Comet 67P also strongly resembles the organic material raining down on Saturn from its innermost ring, as detected by NASA's Cassini spacecraft. Haney and colleagues not only found similarities with other organic reservoirs in the solar system, but many of Comet 67P's organic molecules are also present in molecular gas and dust clouds, which are the birthplaces of new stars. Haney says the findings are consistent with and support the scenario of a shared pre-solar origin of the different reservoirs of solar system organics, confirming that comets indeed carry material from the times long before our solar system emerged. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Space Time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.